Hey, welcome back to the research process. This is establishing a hypothesis. This is episode 3 of the research process, making your prediction. First, let me go ahead and introduce myself. My name's Kate Padua. I am a rising senior at John W. North High School. My research focuses on engineering solutions based in ecology and also research in sociology and psychology. Most recently, I placed at the state level with my team at the California Envirothon 2024. First, let's go over what is a hypothesis so that we're all on the same page. Characteristics of hypothesis. A hypothesis is a proposed explanation of a phenomenon or a prediction of a relationship between variables that will be tested. It should include things that are based on existing knowledge. It also must be testable. It can either be proven true or it also must be falsifiable. It must be able to be proven false. It should also be detailed and clear to make sure you're getting the main idea of your research across. Let's go over what is the research cycle. The research process is not linear, it's a cycle. So step 1 is to define the topic. What are you interested in? What is the general field of study that you would like to conduct your research in? Step 2 is to start narrowing it down. So for example, if you are interested in ecology, you might want to do research that's focused on a particular ecosystem or a particular keystone species and its unique role in that ecosystem. Step 3 is to gather background information. In order to figure out what you don't know and what's yet to be discovered, you should figure out what you do know. Next is to create the research question. Now that you know what you do know and what you don't, you can start looking into what you're wanting to discover or what you're trying to figure out. Next is to develop a working thesis statement. Take that research question and take it into a thesis statement, essentially defining what you're going to be researching, what you're going to be testing out, and how your research is going to be conducted. Step 6 is to find and evaluate your sources. You want to figure out how you're going to be conducting your experiment, what sources you can use to back up your claims, and figure out how you're going to make your reasoning. Step 7, of course, is to cite your sources. Make sure you're giving proper credit from where you're getting your information. Step 8 is to write your paper, putting it all together and creating your research project. So, why do we make a hypothesis? Why is this so important? Well, the purpose of a hypothesis is to guide your research. You want to make sure that you're not going through rabbit holes or getting lost or get off track, which can easily happen when you're looking at lots of details and lots of different data. It provides a clear and focused direction for your study. Next, it helps you make predictions, making specific predictions that can be analyzed after testing. Again, it helps center and focus your study. Next, it offers basis for your testing. It offers a statement that can be either supported or refuted through test. It makes it very simple and very clear what you're trying to do in an either yes or a no answer. It also increases objectivity and decreases bias. It forces researchers to create a clear expectation before collecting data. It ensures that you're not looking at any other variables that might be influenced by bias. Instead, you're looking at data and specific results that you're getting from your research. Next, it creates structure for the analysis. It enables the use of statistical analysis. When you're evaluating an hypothesis, you're looking at a relationship. And this helps with statistical analysis because you're defining and very clearly setting out what your two variables are so you can discover what that relationship is. For example, it helps, this is how hypothesis can help guide your research. If a researcher hypothesizes that a new drug will reduce symptoms of a disease, this guides the design of clinical trials to test the drug's efficacy. The hypothesis tells you exactly what you're looking for. Since we're looking for how a drug will reduce symptoms of disease, we're looking at the symptoms of the patients that the clinical trials are being conducted on. this helps with your prediction. Hypothesizing that increasing light exposure will improve plant growth leads to predictions that can be tested by varying light levels in a plant. So this hypothesis helps you figure out what your your independent variables are. Since you're hypothesizing increasing light exposure, you're going to be looking at different light levels. Here's an example of giving a basis for your testing. A hypothesis that children learn better through interactive activities can be tested by comparing learning outcomes between interactive and traditional methods. So if a teacher notices that children seem to be learning and performing a lot better in interactive environments, that would be the basis for their testing. They would test both interactive activities and traditional methods, where traditional methods would be the control group. This gives her the basis of the testing, and it proposes the initial question and then also leads her in how she's going to answer that question. Here's an example how it increases objectivity and decreases bias. By hypothesizing that a certain diet improves health outcomes before starting a study, researchers commit to evaluating the diet's effects based on data rather than personal belief. So again, since our hypothesis is looking at diet that improves health outcomes, the researchers are not going to be looking at the preconceptions of the people who are taking on the diet. Instead, they're going to be looking at vitals and other data that don't have to do with personal beliefs, because the hypothesis is intending to focus on health outcomes. Next, another example is it provides structure for the analysis. For example, hypothesizing that a new teaching method will improve test scores enables the use of statistical tests to compare test scores between different teaching methods. So since the hypothesis is looking at test scores, we're going to be looking at a wide range or a sample pool of students and all of their test scores. And since test scores vary naturally, these are numbers that we can take in and compare against the different teaching methods and find the relationship between those two. So again, the hypothesis has already outlined for us that we're going to be looking at test scores compared to different teaching methods, so that way we can find any statistical significance between the test scores and the different teaching methods. So how do we actually make a hypothesis? How do we develop the question for our research? Step 1 is to conduct preliminary research. Review existing literature and theories related to your research question to gain a deeper understanding of the topic. Again, you can only figure out what you don't know by evaluating what you do know. So making sure to take in the research of others and making sure that you're well-versed and have well evaluated the given information about your topic so you can conduct proper and thorough research. The next step is to define your variables. Very clearly identify the independent variable, the one that you're manipulating, and the dependent variable, the one that you're measuring or trying to see the outcomes of. So essentially what that means is you want to be very, very, very clear of what you're evaluating, so that way the relationship between those two variables is also very clear, and the basis of your research and when you're collecting data will also be very clear and succinct in what you're looking for. Next is to actually formulate the hypothesis. Now that you've looked at all the background and you've found out what you're trying to test out, all you need to do is put that into words. Develop a clear and concise statement predicting the relationship between the variables. Ensure it is specific and testable. So again, it's really important that this hypothesis is testable. It's something that you can come to a conclusion by with data and different research. A classic example is of essentially a theory that cannot be proven false is non-scientific. So a classic example of this is dogs are better than cats. Better is very vague and it's really subjective. It's not something we can all widely agree upon just from the word better itself. So you want to make sure your hypothesis is very clear and very specific, and also has to be testable, something that you can say and give an answer to. So making sure the hypothesis is testable. So again, the hypothesis can be tested through experiments or observations. It should be possible to measure the variables and observe the predicted relationship. So again, just use example for earlier. Instead of saying maybe dogs are better than cats, you would maybe say cats can jump higher than dogs. So instead of trying to measure the vague and ambiguous concept of betterness, you would be looking at the cat and the dog's vertical, how high they can jump. Next, you want to state the hypothesis in an if-then format. A lot of times, the most simple way to put an hypothesis is in the if-then format to express the hypothesis. Just as an example, that we used earlier, if a plant is exposed to more sunlight, then the plant's fruit yield will be much larger in size, things like that. Next, you also want to consider the null hypothesis. Now, a null hypothesis states that there is no relationship between the variables, so that there is really no correlation between the independent and the dependent variable. This provides a basis for statistical testing. So not only can statistical testing tell you there is a relationship, it can also tell you that there isn't one. For example, if I was testing the hypothesis that if I cross my fingers and wish really hard, then every time I flip a coin, the coin's going to flip on heads. Well, there's no relationship between my superstitions and the randomness of a coin toss. So that would be the null hypothesis, where after lots of testing, after lots of crossing of fingers, and lots of coin tossing, we're going to find that there's actually no relationship between superstition and the flip of a coin. Lastly, it's always important to review after you've done something, come back to it with a fresh mind. You want to refine the hypothesis for clarity, specificity, and testability. Make sure any necessary adjustments are made to ensure it is precise and researchable. Essentially, consider all the things we talked about before and consider it one more time to make sure you've hit all the marks. Thank you so much for watching. Again, that was episode 3 of the research process. Go ahead and move on to the next episode. Thank you so much to Melody for creating this presentation. I hope you learned something, and we'll see you in the next episode.